So in the previous videos, we studied what is cryptography. We looked at the history of cryptography. We even looked at the Caesar cipher. Now it's time to understand the various types of encryption. And the first one that we will study is a symmetric encryption. Now, as I always say, guys, always look at the root word. So the root word here is symmetric. So what does symmetric stand for? Symmetric actually stands for same, right? Now let's try and understand what it means. Let's say you have an original text, which was, let's say, hello, right? And you need to send this to your receiver, right? What it says is you need to encrypt this using a key, right? Let's say we have this key, right? You use an algorithm, you use a key, and let's say that key was, in taking an example of Caesar cipher +3, right? So use the key and you get a scrambled data or the garbled characters. Now, when it comes to the receiver gets it as a ciphertext. What the receiver needs to do is use the same key. So the key that I used here, I need to use the same key here. So what I'll do is, let's say my algorithm says that when you're doing an encryption, you need to go forwards, and when you need to do a decryption, you need to go backwards. But my key here is the 3, right? The number 3, that how many times do I need to go up, front and back, right? So if you see here, when I'm encrypting the data or when I'm decrypting the data, I'm using the same key, right? That is what is symmetric encryption all about. Now let's study it. So symmetric cryptography uses the same key. I think I've almost repeated this thing almost 10 times since the time we started our video. So symmetric cryptography, symmetric, same, similar. Remember that you always use the same key when you're encrypting or decrypting the data. Very important. The most commonly used symmetric encryption algorithm. So we will study a lot of, so there is one symmetric, then there is one asymmetric. In asymmetric, you basically use a key pair or a key combination. We call it public-private key pair, and we will take a look in the following videos. But what I'm trying to say here is that when you talk about symmetric encryption algorithms, then the key encryption algorithms, the most important encryption algorithms that are available are DES, which stands for Data Encryption Standard. Nowadays, we use AES, which is the Advanced Encryption Standard, and there is also Blowfish, right? So the symmetric cryptography is considered to be really fast because you don't have to get a different key pair on the say the sender side and receiver side, or use a different key combination to get your data. You're just using the same key, right? I'm also encrypting the data using the same key, and the person who's getting the message is also decrypting the message using the same key, because it uses less computation power. So it's pretty good if you think in terms of the World Wide Web, where we are talking to different parties. If we are able to use symmetric key, then it would be so good, but it has its own challenge as well. And the biggest challenge is key distribution, right? Now, let's say I'm sitting in London and this guy is sitting in say US, right? So if you just try and imagine, let's say we are sending this, how would the guy sitting in London know that I need to use this key, or I need to use a cipher code of 3, right? So the biggest challenge it introduces is key distribution. What it means is, how do I tell the guy sitting in US that you have to use this key? Either I could post that message or I could send by certain ways. Now, if you just imagine, if you do that, then you're always prone to some man-in-the-middle attacks, right? So, and that's what the World Wide Web is all about. We have a combination, and we will study that. You always use symmetric encryption, you use asymmetric, and use a hybrid encryption as well. So, but since now we are studying symmetric encryption, so the biggest advantage of symmetric encryption is it is very fast, it uses less computation power, but that are its advantages. What are the disadvantages? The biggest challenge is key distribution. How do I share my key with the receiver, right? So as it says, it is necessary to securely distribute the same key to both sender and receiver without anyone else getting access to it. So it's quite straightforward, as I said. So the biggest challenge is you need to distribute it, but you need to securely distribute it. And we will see how it is done in the upcoming videos. And now it talks about what are the different use cases. So use cases are just simple. As you can see, I'm sending a hello and I'm sending from sender to receiver. It's basically for securing the communication between two parties, protecting the stored data, and providing secure access to systems and networks. So if you want to provide secure access to systems and networks, we use a symmetric encryption. Like if you guys have studied Oracle, then we talk about TDE. TDE uses symmetric encryption, then SSH can is based on that. So what I'm trying to say is there are a lot of use cases for symmetric encryption. But again, if there is a use case, you need to be aware of attacks as well. It's vulnerable to attacks such as brute force, where an attacker tries all the possible combination of keys. So the attacker knows that in symmetric encryption, the encryption and decryption keys are the same. So based on that, they can try a brute force, where they can try so many different combinations of keys going in one go, and they can try and break that. Now it says, yes, there are ways to enhance security, and symmetric cryptography can be combined with other techniques such as hashing, salting, key stretching, right? So that is quite important, and we will study all these features. What it is trying to say is, even though symmetric encryption is quite important and is actually used, but you can make symmetric encryption really strong if you do other techniques or use symmetric encryption along with other techniques such as hashing. You can do some kind of like a hashing algorithm. You can even use some salting and key stretching as well. And we will be studying these as well in more details in the upcoming chapters. So the message here is, we are studying symmetric encryption. Symmetric encryption, remember, and the last time I'm saying this word, symmetric stands for similar or same. So the same key is being used when you're encrypting the message, and the same key is used when you're decrypting the message. Thanks for watching.